Good morning, students. So today we can start our fifth module, and the syllabus includes pile foundation and point bearing and friction pile, bearing capacity of pile using using IS static formula and dynamic formula, then pile law test, group action, group efficiency, and capacity of piles. So up to this we have discussed the different types of shallow foundation, design of shallow foundation, etc. So now onwards we can discuss about deep foundation. So deep foundations are used when our surface soil is unsuitable for shallow foundation. That is, the hard stratum is very deep. So in that case, the depth of foundation will be very high comparing to the width. So that type of foundation is deep foundation. And the most common type of deep foundations are piles, pier, caissons, cofferdam foundation, etc. Okay, and in this module, we are going to discuss about pile foundation. Okay, so pile means it is a slender structural member. It can be made up of steel, concrete, or wood. And pier is similar to pile foundation, that is a cast in situ pile having diameter which is greater than 0.6 meter is usually known as pier. It's also a type of deep foundation. Okay, next is caisson. Caisson means it is a hollow water type box or chamber, and it is usually used as a foundation under water. That is caisson. And this cofferdam foundation is also a type of sheet piles which is founded under water. So these are different types of pile deep foundation. So we can discuss detail about pile foundation. Okay, so what is meant by pile? So pile means it is a slender structural member and can be made up of concrete, steel, or wood, or it can be made up of combination of these materials or composite material. Okay, so pile is a slender structural member made up of steel, concrete, or wood, or a composite material. And this pile can be driven in different ways. That is, it can be driven into the soil. Pile can be driven into the soil, or this pile can be formed inside by excavating a hole and filling the hole with concrete. Okay, that is actually this is slender structural member. So this structural member can be directly driven into the soil, or we can create some hole into the on the soil, and we can fill the hole with concrete. Like that we can form pile at site inside. Okay, so pile foundation means it's a type of deep foundation in which the loads are taken to a low level by means of vertical members, and that vertical member is known as pile. Okay, so it's a type of deep foundation, and the vertical member may be of timber, concrete, or steel. And uses of pile, that is necessity of pile foundation, or the situations where we are under which we are going for pile foundation. So when the load of the superstructure is very high and the distribution is uneven, we are adopting pile foundation. At that case, we cannot go for shallow foundation. That is one situation. And also, when the topsoil has a poor bearing capacity, also we have to go for deep foundation like pile foundation. Okay, and the next situation, the subsoil water is high, so that pumping of water from open trenches for the shallow foundation is difficult and uneconomical. That is, if the subsoil water is high. So at that case, we have to pump out this water before constructing the foundation. So at that case, it is very uneconomical if we go for shallow foundation. So at that situations, that is, if the subsoil water is high, we are adopting pile foundation in order to reduce the cost of construction. And also, if there is large fluctuation in subsoil water level, also pile foundation is the best. Next case, the structure is situated on seashore or river bed where there is danger of scouring action of water. That is, if there is any danger of scouring action of water, pile foundation is the best method of foundation. And canal or deep drainage lines exist near the foundation. If there is any canal or deep drainage line which is existing near the foundation, we can adopt pile foundation for our area. And for foundation of transmission tower and offshore platforms, That is, the foundation of transmission tower and offshore platforms are usually pile foundation, because these structures are subjected to uplift forces. So in order to withstand this uplift force, the best type of foundation is pile foundation. So in these situations we are going for pile foundation. Okay. Next, factors affecting selection of type of pile. That is, there are different types of pile. So the factors which are affecting the selection of piles are nature and type of the structure. What type of structure we are going to build on the soil. Then location of the structure. Then material, equipment and fund availability. Then type of soil and its properties. Then groundwater table, the level of water table. Then durability of pile. Then length and number of pile. Then case study of adjacent buildings. That is, the effect of adjacent building is very important as far as we are going for a new structure. Okay, so if the adjoining structure is very high, we have to go for some good type of foundation in our area. Like that, there should be a case study of adjoining building. Then next is facility of pile driving, facility for pile driving. Then erosion of soil near the structure. So based on these factors we are selecting the type of pile. Next we can discuss the classification of pile, and the piles are classified based on three criteria. First one based on function, second one based on material, and third one based on method of installation. So first we can discuss about the classification of pile based on function. So based on function, piles are classified as end bearing pile, friction pile, compaction pile, tension pile, anchor pile, fender pile and sheet pile. So we can discuss one by one. First one, end bearing pile. Okay, so end bearing pile means this is the pile, and here this pile penetrate through the soft soil and the bottom or tip rest on the hard strata. Okay, that is, this is the soil strata. That is, you can see here there is weak soil, and after this weak soil there is hard soil or strong soil or rock. Okay, so in this type of foundation, that is, here the pile penetrate through this soft soil, and finally the bottom or tip rest on the hard strata. That is, the load which is coming over the pile is finally transferred into this hard strata. So this is known as end bearing pile. So it works as similar to that of a column. That is, here QU means this is the load which is coming over the pile, and this QU ultimate load is equal to the pile load. That is, this load is finally transferred to the hard strata. So this is the type of pile, and it is known as end bearing pile. That is, the load is finally transferred into the hard soil strata. And next, second type is, so this is also end bearing pile. That is, the pile penetrate through the soft soil and the load is finally transferred into the hard rock. And in the second type, that is in friction pile, here the loose soil will extend to a greater depth. That is, there is a loose soil which is extending for a greater depth. So the pile are driven at a depth when friction resistance developed equal to the load. That is, here the load is transferred through the frictional resistance offered by the pile. That is, here the pile cannot rest on the hard stratum, because here hard stratum is very far from the ground level. So here load is transferred through the friction resistance which is developed, and this friction resistance developed is known as skin friction. Okay, so here this is the load which is transferred into the pile, and through the skin friction which is developed between this pile and the soil, the resistance developed. So this skin friction actually resists the load which is coming over the pile foundation, and here in this type of friction pile, the pile is not resting on the hard stratum. Okay, that is, here in this level there is soft soil with increasing stiffness as depth increases. There is no hard stratum. Okay, that is, here loose soil extend to a greater depth and the piles are driven at a depth when friction resistance developed equal to the load. Friction developed, that is skin friction, will be equal to the load. QU is equal to QS. So this is the second type of pile, that is friction pile. Okay, so this end bearing pile, the differentiation between end bearing pile and friction pile is very important. In the case of end bearing pile, the pile penetrate through the soft soil and finally it rests on the hard stratum. So this load is finally transferred to this hard stratum. Okay, that is QU is equal to QP. Ultimate load is equal to this pile load, and it is transferred into this hard stratum. But in the case of friction pile, the hard stratum is very far from the pile. So it is not resting on the hard stratum. So here the load is resisted by the development of skin friction between the pile and the soil. Okay, there is development of skin friction. It is marked in green color. So this QU is equal to QS. This Q is resisted by the skin friction which is developed between the pile and the soil. Okay, that is known as friction pile. That is, in friction pile there is only soft soil. Okay, so this figure shows an bearing pile, that is load is transferred finally into the bedrock, and here it is pile driving support through the skin friction. Okay, and the third type of pile is compaction pile, and in this type of pile the pile do not carry any load. This pile is not functioning for carrying load, and it is usually for increasing the bearing capacity of soil. That is, compaction pile is used to increase the bearing capacity of soil. Okay, so this shows compaction pile, and it is not used for carrying any load. Next is tension pile. Tension pile means these piles are actually in tension. That is, these piles are used to anchor down structures which are subjected to hydraulic uplift forces or overturning forces. There will be uplift force or overturning force. So in order to resist this overturning force, we are providing this tension pile. This is when structure subject to uplift due to hydrostatic pressure or overturning moment, and it is also known as uplift pile. Okay, so that is known as tension pile. Next is anchor pile. Anchor pile means these piles are used to provide anchorage for anchored sheet piles, and these piles provide resistance against horizontal pull for sheet pile wall. Okay, this provide anchorage against horizontal pull from sheet pulling or any other pulling. Okay, that is anchor pile, as the name implies. These are used to provide anchorage for anchored sheet pile. So this is the example showing anchor pile. Next is fender pile. Fender pile means these are used to protect waterfront structures against impact from ships or other floating objects. Okay, so in order to protect the waterfront structures from the impact of ships and other floating object, we are adopting fender pile. Okay, so these are also sheet pile which are used to protect waterfront structures from the impact of ships and vessels. Next is sheet pile. Sheet piles means sheet piles form a continuous wall or bulkhead, and is used for retaining earth or water. It is actually used for retaining earth or water. Okay. Next, these sheet piles are classified as concrete sheet pile, then steel sheet pile, or timber sheet pile. This is also used as a bulkhead or impervious cutoff in order to reduce seepage and uplift under hydraulic structures. Okay, that is sheet pile. Next, so these are the classification based on function, and next is the classification based on material. Okay, so based on material, it is classified as timber if it is constructed using timber, then H pile, that is construction using steel, then pipe, concrete, composite. That composite means it may be combination of steel and wood, or concrete and wood, etc. So steel pile means there may be H pile, that is in the shape of H, steel in the shape of H, then circular pile, the shape in circular shape, and tapered pile, that is end is tapered like this. So these are different types of steel pile. Next is timber pile. Okay, then composite pile means composition of one or two material, that is composite pile. Then last is the classification based on method of installation. Okay, so based on this method of installation, the piles are classified as driven pile, driven and cast in situ pile, bored and cast in situ pile, then screw pile, then jagged pile. So first one is driven pile. So here the piles are driven into ground by applying blow with a heavy hammer. Okay, that is piles are driven using heavy hammer blow. Timber, steel and precast concrete pile are installed by this driving mechanism. Okay, so this figure shows the driving mechanism. And next is driven and cast in situ. And here the piles are formed by driving a casing. Piles are formed by driving a casing with a closed bottom. Okay, with a closed bottom and into the soil. That is, first we are driving a casing, and later this casing is filled with concrete. Okay, that is the in this type, first we are driving a casing with a closed bottom and into the soil. Next, in the second stage, we are filling the casing with concrete, and finally the casing may or may not be withdrawn. Some case casing will be under the ground, or in some cases we can withdraw the casing. This after the concrete is set, we can remove the casing also, or we can remain the casing at the place also. So this is driven and cast in situ pile. That is, here a casing is inserted into the ground and the casing is filled with concrete, and finally we can remove the casing out. And third one is bored and cast in situ pile, and these piles are formed by excavating a hole into the ground, and then the hole is filled with concrete. Okay, here there is no casing. Here we are drilling a hole, and this hole is filled with concrete. That is bored and cast in situ pile. Then this is screw pile. Screw pile means these piles are screwed into the soil. That is, this is screwing mechanism. That is, the pile is screwed into the soil using screwing mechanism. Then next is jagged pile. Jagged pile means these piles are jagged into the soil by applying downward force with the help of hydraulic jack. Okay, here the pile is driven using the mechanism of hydraulic jack. That is, this classification is based on method of installation. That is how we are installing the pile into the ground. So here in the case of jagged pile, we are installing these piles are jagged into the soil by applying downward force with the help of hydraulic jack. So it is known as jagged pile. So these are the classification of pile. Next is a special type of pile, that is under-reamed pile. Okay, and these under-reamed pile are developed by CBRI for serving foundation for black cotton soil. So this is actually for black cotton soil, and this is highly expansive soil and filled up ground, and also for filled up ground and other type of soil having poor bearing capacity. So usually for soil with a poor bearing capacity or highly expansive soil, we are adopting under-reamed pile. Okay, and under-reamed pile is bored cast in situ concrete pile, and it is a bored cast in situ concrete pile having one or more bulbs or under-reamed on at its lower level. That is, there are so much bulbs at the lower level of the pile. Okay, so this is bulbs which is created, and the bulb or under-reamed are formed by under-reaming tool. Using under-reaming tool, we are forming this bulb or under-ream. Okay, so it is known as under-reamed pile. The bulbs are created, and the diameter of pile is 20 to 50 centimeter, and the bulb diameter is 2 to 3 times that of diameter of pile. Okay, and the length of the pile is 3 to 8 meter, and the spacing between the pile is 2 to 4 meter. Then load carrying capacity can increase by making more bulb at the base. That is, if we increase the number of bulb, the load carrying capacity also increases. Okay, that is, if we are expanding the diameter, the load carrying capacity also increases. Okay, so this type of under-reamed pile usually used for soil having very low bearing capacity. And the vertical spacing between the two bulb, that is the spacing between these two bulb varies from 1.25 to 1.5 times the diameter of the bulb, spacing between the two bulbs. And for black cotton soil, the bulb is increased bearing capacity. For black cotton soil, the bulb is to increase the bearing capacity and also provide anchorage against uplift. Okay, so for black cotton soil, in order to increase the bearing capacity, we are using under-reamed pile, and also it provide anchorage against uplift. So this is under-reamed pile. Okay, so this is about the classification of pile and use of pile, for how many situations for we are adopting this pile foundation, and we have studied about under-reamed pile. Thank you.